Hello everyone. In this presentation, we are going to understand the floating point number representation in IEEE 754 format. So, how to represent the smallest and largest numbers is the big thing. So, for example, any smallest numbers and any largest numbers can be represented in a processor only through floating point format. Say, for example, the smallest number is mass of an electron. This can be represented only in mantissa and exponent. Example for the largest number is mass of an earth. So the universal standard for representing the smallest number and largest number is IEEE 754 floating point format. The float variable in C program use 32-bit representation of IEEE 754 format is single precision format. 64-bit representation of IEEE 754 format is double precision format. So the following examples justify the use. Here, the common floating point number is pi, which is 3.14. How this pi value, which is 3.14, is represented in IEEE 754 format? We can see it with an example. So normally we use 8015 microcontroller. So with the help of 8015 microcontroller, it is very easy for us to understand. So when we write a C program, we use hash include reg52.h for 8051, and when we use float variable, so float of pi, so pi equal to 3.14 because it is a constant, so pi equal to 3.14 is fixed, and void main and while 1 have nothing. So there is a constant, float constant, which is 3.14, and the IEEE 754 format of 3.14 is 4048 FIC2. Okay, so this can be represented as in 32-bit format like this. So where the first bit is sign bit, which is 3.14 is positive number, so it is 0. Then it is an exponent, so exponent is 128, which is represented as 100000000, and the rest is 23 bits are mantissa. When we find the hexadecimal equivalent of this, then it will become 4048 FIC2. So even though it is 8051, it can support the float variable. Whenever the controller supports float variable means it will be represented only in IEEE 754 format. So there is a small memory window here. In this memory window, the same value is being represented as shown. So the float variable pi equal to 3.14, and its value is stored in the data memory of 8051 microcontroller, as you see here. So here from the data memory location 89AB, the 4 locations, those 32-bit data are being stored. You can see 4048 F5 and C3. Okay, so this justifies 8051 can also support IEEE 754 floating point format for representing any floating point numbers. Similarly, we can see one more example. So 2.2 is another floating point number. How to represent this 2.2 in IEEE 754 format means the same way. The IEEE 754 format equivalent of 2.2 is 400 and CC. Okay, so when it is represented in IEEE 754 single precision format means sign bit followed by 8-bit exponent, then 23-bit mantissa like this. So C equal to 2.2 represented in floating point number from the data memory location 8 to B, which is 400CCCD. Okay, so this justifies any floating point numbers can be represented in fixed point processor with the float variable in IEEE 754 format, which is very clearly shown. So we are very eager to know how to convert the given floating point numbers into IEEE 754 format. We'll see an example, then it will be easy for us to understand. Let us take this 2.2 as itself as an example, how to convert this 2.2 floating point number into IEEE 754 format. Okay, so normally when we represent 2.2 in binary means 2 can be represented as 10 base 2, and 0.2 to be represented in binary means 0.2 into 2, which is equal to 0.4. So we will represent it as 0 like this as shown. So then 0.4 into 2, which is 0.8, that 0 has to be shown. Then 0.8 into 2, which is 1.6, and that 1 is given, and 0.6 into 2, which is 1.2, which is represented as 1, and again this repeats. 0.2 into 2, 0.4, and 0.4 into 2, 0.8, which is 0, and 0.8 into 2, 1.6, which is 1, and 0.6 into 2, 1.2, which is 1, and then this repeats, it goes on. So 2.2 when represented in binary means 10.0011001100110011 it goes on. Okay, so this is the binary representation of the floating point number 2.2 as we see here, but this has to be represented in IEEE 754 format. That is our expectation. So 2.2 represented in IEEE 754 format means we have to bring it to 1 point as shown, 1.000110011 into 2 power 1. There is a bias of 127. The sign bit 2.2 is a positive number, so sign bit will become 0, and the bias of 127 and this 2 power 1, so 127 plus 1 will become 128, which is an exponent. So there is a bias of 127 plus this 2 power 1, so there is one decimal point float is shifted towards left. So we have represented it 2 power 1, so that 1 has to be added with the bias of 127. So 127 plus 1 is 128, which is an exponent, which is 100000000, which need to be represented it here. Then the remaining numbers from the decimal point, remaining 23 bits are the mantissa bits, which has to be written like this. So sign bit is 0 and the exponent is 128, which is 80, 100000000, and the remaining bits 000 next to the decimal point. Remaining 23 bits will become the mantissa bits when it is represented in hexadecimal equivalent. So 0100 is 4 and 0000 is 0. Then other 4 zeros are 0. Then 1100 is C, 1100 C, like this. It will become 400 and CCC. So like this, we can represent any floating point numbers in IEEE 754 format. Okay, we can see again the 3.14 is another example. So 3 when represented in binary, which is 11 base 2, and 0.14 into 2, 0.28, something like that it goes on, and finally we will get 11.00100111010111000000101. It goes on. Okay, so when we bring it to 1 point, as we all know, the 3.14 when it is represented in single precision IEEE 754 format means the 3.14 is positive number, so sign bit will become 0, and the bias is 127, and here it is 2 power 1, so 127 plus 1 is 2, 128, then mantissa 23 bit right to the decimal point. When finally when represented in hexadecimal, we can see 04048F5C2. Okay, so 0100 is 4 and 000 is 0, like this it goes on. So 3.14 binary equivalent is 110010, it goes on, and when it converted to the IEEE 754 format in a simple way like this, so IEEE 754 single precision format of 3.14 is in hexadecimal when it is represented means 0x4048F5C2, etc. So this is how it goes on. Then consolidating, so both pi and c represented the float variable like this. So pi is 3.14, its IEEE 754 format is 4048F5C3, and it's represented like this. And similarly, c equal to 2.2 means its IEEE 754 format representation is 400 and CCCC. Okay, so this is the way we have to represent all the floating point numbers in fixed point processor in IEEE 754 single precision format. Thank you.